Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
So are we charged up to solve few numericals? Yes, we are. So in last lecture itself, I said that uh, we will be solving few numericals, okay, in this lecture. Now we have studied what happens when AC is applied across RLC, series combination of RL, LC, RC and RLC together. So today what we are going to do is we are going to see the numericals. What kind of numericals are asked in examination? So please keep this thing in your mind that whatever numericals we are solving, these are taken from previous year's question paper. So these things are very, very important. Okay. These numericals, if you solve them properly, can fetch you very good marks. Fine? Okay. So let us move ahead. Oh my God. Why is this blank slide? Well, actually, I thought I would take a quick revision on conversion of rectangular into polar and polar into rectangular form. This was my, last minute plan. I had some other numerical in the sequence, but I thought, see, you must have done that conversion. I know, but that by now you must have forgotten it. So it is always better to revise, few concepts which are important. And now this rectangular to polar, polar to rectangular, we are going to use it quite often. Okay. So basically we have, just a second, I'll enable my ink. Fine. So we have, we can represent, as always I have some issue. Yes, I have some issue means I have some issue with my pen. Yes, I don't have any issues. Yes, so rectangular format, and here we have polar format. Fine. So how do we represent the vector in rectangular format? We represent it by this. Okay, and how do we represent it in polar? We say it is r theta. Yes, so let us first understand how do we go about this conversion. Fine, because these are actually equal, right? Yes. So basically, if I want the conversion from rectangular to polar, see, again, you have all the, gadgets with you, because nowadays calculators, they allow you to convert it. But then we should know the conventional method, isn't it? Yes. So how do we get this R? So R can be calculated by this equation. Fine. And theta, as we have already done this, it is y by x, so in this case it is b by a. Okay, so this was rectangular to polar. So you got r, you got theta, so you can directly represent it by r theta. Fine. So what happens when we have r theta and we need to convert it into a plus bj? In that case we have r and we have theta. Okay, so a is given by r cos theta, and then b is given by r sin theta. So now you have a and b, so you can very well convert it into a plus bj. Remember, in maths we have I, we represent imaginary by I, but here when we study electrical engineering, then we represent imaginary part by j. Fine. So it would be better if we take a small example. Okay. So suppose I have any number, say 4 plus 5j. Okay. 9 is lucky for many people. Fine. So I have taken 4 plus 5j, which makes it be 9. But don't get confused. This is not the equivalent value. Fine. So how do I get r? So R is going to be 4 square plus 5 square. So it makes it 16 plus 25. So the square root of this 16 plus 25 comes out to be 6.40. 16 plus 25 comes out to be 41, right? So 41 square root comes out to be 6.40. So this value is nothing but R. Okay, so I want theta. So how to calculate theta? It is tan inverse 5 upon 4. So 5 upon 4 comes out to be 1.25. Okay, so tan inverse 1.25. Okay, so by using the calculator we can find out that theta is 15.34. Fine. Okay, so how do I represent this signal? Not signal. See, signal is actually occupied all over in my mind that I always say signal, signal, signal. So this becomes equal to 6.40 with angle 51.34. This is how it is represented, degrees of course. Fine. So you can very well use r cos theta and then r sin theta. So you would be getting this. Do you want me to show the same to you? Okay, fine. We should always verify. Why to have doubt in my mind? So we'll go the reverse way now. Yes. So basically now here we have 6.40 and angle was 51.34. So how to get A? A is R cos theta. So it is 6.40 cos 51.34 plus J R sin theta. So it is 6.40 sin 51.34. Now please calculate the value of cos 51.34 and tell me. After you tell me, I'll write that. I was just joking. So I have already calculated it. So whatever value comes out to be of cos 51.34, I'll multiply it by 6.40 and it comes out to be 4. And then I'll write J. Then I have sin 51.34, whatever value comes out, I'll multiply it by 6.40. So that value comes out to be 5. Right? So this is how actually rectangular to polar or polar to rectangular conversion is done. That is not very difficult. Of course, you can use your calculator also. But as I said, we should know what is a conventional method to do that. Suppose if sometimes calculator doesn't work, then so we should know, how to go about it. Okay, fine. So we are ready with the numerical. So here a circuit is given and I have not written the statement because actually we are supposed to find out all the impedances in the circuit. Okay, fine. So we have R which is 250, we have L 650 millihenry and we have C 1.5 microfarad and 120 volt 60 hertz AC is applied across this. Fine. So as soon as I get L and C, the first thing first is we should calculate the reactances, because if we want to calculate impedance we need to have reactances with us. Okay, so first we'll calculate XL. So we know how to calculate XL, 2 pi FL. So we will put all the values. Now 120 volts 60 hertz means 120 volts is the RMS value and 60 hertz is the frequency. Frequency is nothing but F. L is 650 millihenry. So we will put all the values, okay, and we will get XL. So XL comes out to be 245.04 Fine. Okay. Um, we shall move ahead. So it is 245.04. The next step is to calculate XC. So it is 1 upon 2 pi FC. So again we will put all the values and we will calculate XC, which comes out to be 1768.4 ohms, or it comes out to be 1.7684 kilo ohms. Fine. Yes. So secondly, what is the impedance of resistor? So resistor does not have any phase shift, right? So what we will do is we will write it in the form of impedance. So what is the magnitude? 250 ohms. And what is the angle? 0. So both in rectangular form and imaginary form, the angle and imaginary part becomes 0. So it can be represented as 250 plus j0 or 250 angle 0. Okay, so we have this ZR with us. Fine. Then ZL. Now what is going to be ZL? So ZL will be, real part will be 0, because it does not have any associated resistance. Generally inductance has some associated resistance with this, which is not connected externally. It is internal resistance, but this might be a pure inductance, so it is not specified. Fine. Later we are going to see those cases, so let us not bother about that right now. Fine. So this is a pure inductor, so real part is 0. We just have imaginary part. So we have 0 plus j 245.04. Okay, when the same is converted into polar form, we have 245.04 and angle 90. Now how did I write 90 degree directly? Because I know that it is an inductor, and here we have the angle of 90 degree. Similarly, in the case of capacitor, I would be writing minus 90, because in earlier cases, remember we used in the last lecture we had IR to be like this, correct? And here we had IL, and here we have I shall take VR rather. Yes, VR, VC, and here we had VL. So the resultant was VL minus VC. Please don't mind the handwriting. Actually my handwriting is good, but then perhaps on the screen it is like this. Doesn't matter. Well, so I have 245.04 and the angle is 90 degree, right? Because I know. And in case of capacitance, what will be the angle? It is going to be minus 95. Okay. So this is ZC now. Okay. So as I've already told you that it is minus 90, and we will have minus sign here for imaginary part. So we have 0 minus j, and what was the reactance? 1.76 K. Don't forget to write K. Fine. That stands for kilo. So if it is represented in polar form, it is 1.76 K. Angle is minus 90. Okay, fine. So here we have represented the same circuit with impedances. But these are individual impedances, okay? So we have to find collective impedance. So that is going to be the algebraic sum. So we just have to add these things. So all the real parts will be added together and all the imaginary parts will be added together. Now please pay attention that in case of capacitor we have put the minus sign. Okay. So when I said imaginary parts are going to be added, means it means that that minus sign has to be taken into account. Okay. So it is going to be 250 plus 0, and then it is going to be 0 plus 245.04 minus 1.7684 kilo. Okay. So this is the final value of impedance. So 250 plus 0 is the same. Then you have 0 plus 245.04 minus 1.7684 kilo. So that comes out to be minus 1.5233 kilo. Okay. Now I've already told you. Now I hope you understood why at the last moment, why I wanted to teach you how to convert rectangular into polar, because here we require this. Okay, so please use your knowledge to check whether these values are right or not. Now you know how to convert it into polar form. Fine. So I hope this is clear to you. Okay, so let us move to the next numerical. Next numerical says an alternating voltage is represented by V is equal to 141.4 sine 377t. Calculate the maximum value, frequency and the time period. Let me repeat that all these problems are taken from previous year's question paper. So these problems are simple, but we have to have our basics clear. So of course we can secure marks. Okay, so first we will write V is equal to 141.4 sine 377t. So do you find anything similar we have heard of? Yes, this is something like Vm sine omega t. Correct. So what we are going to write is, we will be writing the standard form and then we will be comparing it. Very good. So compare the given equation with the standard equation, which is V is equal to Vm sine omega t, or of course omega is 2 pi ft. So after comparing the maximum value, Vm comes out to be 141.4 volts, and then 377 will be compared with 2 pi f. Okay. Yes. So frequency comes out to be 377 upon 2 pi. So pi value is 3.14. So the frequency comes out to be 60 Hertz. Now how will I calculate the time period? Come on, come on. I want the answer. What is the relationship between frequency and time period? Yes, exactly. It is reciprocal of each other. So time period is reciprocal of the frequency. So finally I get time period to be 16.67 milliseconds. Okay, now again please pay attention that milli is small m and seconds is also small s. Now why do I write small s? Because though these SI units which have not been kept on any scientist's name, those units are taken to be written in small letters. So if anything is written in capital letter, it means it is kept on some scientist's name. Say Newton, so it is capital N, right? Kelvin, capital K. Now why I am telling you this is, suppose you write it, you don't have this concept in your mind, and you will write, okay, S is second, so you will write like this, but this S is actually Siemens. So it is used for resistance, admittance. At the time of resistance and admittance, we will use this Siemens unit, okay, which is again kept on scientist's name. So capital S is for Siemens. So this is wrong. So you have to write small s. Please pay attention. You might be feeling that why I am telling you these things, because these things carry some meaning. Fine. Okay, so we are good to go for the next numerical. Don't worry, this is going to be the last for today's class. Okay. Yes, so in the circuit shown, calculate current V1, V2 and power factor, which is PF. Fine. So the circuit is shown. Okay, here we have RL, then we have RL and C. Very good. Fine. So V1 is the voltage across the first combination of R and L, and V2 is going to be the combination of R, L and C. Okay, so we will write all the given values and then we will see what all can be done. So now, as I have already told you, first we should calculate the reactances. So first we will calculate XL1, which is 2 pi FL. So we will put the value of the frequency. Frequency is 50 Hertz. See, here it is specified 50 Hertz. So we will write 50. L is 0.05. So we will put that value and we got XL is equal to 15.71. Now again, I have a small piece of advice for you. Please do not copy the answer. Okay, take some time, pause the video, use your calculator and check whether you are getting the same value or not. Okay, yes. So the next is XL2. So again, we will put the value now here 0.01. Okay, so we got this. Fine. So now we will calculate XC. Here we have only one capacitor, so we need not specify as 1 or 2, it is XC is sufficient. So we will put all the values. Okay, 1 upon 2 pi F is 50 and C value is 50 microfarad. Micro is 10 raised to power minus 6. So we got XC is equal to 63.66. Okay, now we'll write the impedance. Now we know how to write impedance, right? So we have to add all the imaginary parts and the real parts separately. Okay, so here we have two resistances, so 10 and 20, they denote resistance. Now what is plus J 15.71? Plus J 15.71, this represents this inductance, correct? And this represents this one, and this minus J 63.6 represents the capacitive reactance. Okay, we have seen that in earlier problem, numerical problem. Yes, so we will add, I'll just erase it. Yes, now it is clear. So 10 plus 20 comes out to be 30, and all imaginary parts are added with the signs, so we get minus J 16.53. So again it can be written in rectangular form like 30 minus J 16.53, or we can convert it into polar form, which comes out to be 34.25, and angle comes out to be minus 28.85. Okay, yes, so impedance is done. So now we will calculate the current. Current is voltage upon impedance. Voltage is given as 200 volts and impedance we have calculated as 34.25 and angle is minus 28.85. But at the time of calculation of current, we won't take the angle. We will only take the magnitude. Fine. So magnitude is 34.25. So it is 200 upon 34.25. That comes out to be 5.84 amperes. Do not forget to mention the units. Okay, they also carry some marks. Now V1 and V2. Okay, yes, so here we got the current 5.84, right? Yes, so here just to show that as a vector, we have shown the magnitude as this, and this was Z1. Okay, Z1 is a combination of R and L. So this is Z1. Fine. So what is going to be V1? It is going to be again Ohm's law, I into Z1. So we will simply multiply it. Okay. But since we have here in rectangular form, if we multiply, it would be a bit complicated. It is not that complicated, but when we represent it in polar form, the multiplication is the direct multiplication. Okay. But then please remember that phases are added. They are not multiplied. Only magnitudes are multiplied. Okay. So this and this quantity, these two are multiplied and these two are added. Fine. The phases are added. Okay. I'll erase all. This is better. So I've got V1. Okay. Yes. So 18.62 into 5.84 gives me 108.74, and 57.52 plus 0 gives me, of course, 57.52. Don't multiply it by 0 and then say angle is going to be 0. No, angles are added. Sorry. Yes. So not Z2. So Z2 is also calculated in the similar manner, but for Z2 you have R, L and C. Okay. So this is how we have written it: 20 plus J 31.42 minus J 63.66. So the imaginary parts are added with minus sign together. So basically it is subtracted. So it is now 20 minus J 32.24. Again this is converted into polar form. So we got Z to be 37.94 with angle of minus 58.19. And so V2 will be calculated as I into Z2. So I into Z2. Okay. So as I said, magnitudes are multiplied, so you have 37.94 multiplied by 5.84, so that comes out to be 221.57. Okay, so minus 58.19 remains as it is. So this is how we calculated V1 and V2. So what else is remaining? Power factor. Okay, so power factor is nothing but cos phi. Fine. So what is phi here? It is 28.85. Okay. Sorry. So this is power factor. Okay. Now why it is leading? Because it is a positive value. So I would say it is leading. Had it been a negative, say minus 28.85, then I would have said it is lagging. Now since it is positive, I would say it is leading. Okay. So I hope you understood this problem. We shall meet in the next class. Till then, see you and keep studying. Bye-bye.